We covered a lot of ground starting from the OSI protocol stack to the physical layer, link layer and network layer. Before we proceed further, I think it's a good idea to take stock of what all happened and where we stand currently. This is you and this is your communicating device. You want to use your communicating device to talk with other communicating devices. Maybe you want to use it to download information from a server. You may want to use it to communicate with your other friends via Skype, or you may want to use it to send emails to your friends. This communication process is a complex process, and we have seen that it makes sense to divide the tasks into layers. That is where we talked about the Internet protocol stack, where the functionality was divided into the following layers: the application layer, the transport layer, the network layer, the link layer, and the physical layer. We haven't yet covered these, so for now I will ignore them. Let's focus on this. The job of the network layer, as we have seen, is end host delivery. The job of the link layer is next hop delivery, and the job of the physical layer is bit by bit delivery. We saw that to communicate, addressing is important. So the addressing that is employed at the network layer is the IP addressing, and the addressing that is employed at the link layer is the MAC addressing. Also, all this deals with bits, whereas the physical layer deals with signals. You that are here, let's say, want to contact the Google server. Based on whatever we have learned so far, let's see how you can contact the Google server. All you know up till now is the name of www.google.com, and you want to contact the specific server. We didn't cover this aspect, but there is a service called DNS that is going to convert this name into an IP address, and based on that you will get the IP address corresponding to this server. Let me represent this by a capital G. You yourself will have an IP address. Let me call the IP address that you have acquired by H. How do you acquire an IP address? You could manually configure it, or you could obtain through a DHCP server, but for now let's just assume that you have manually configured this. Now that you have H and G, you are now generated this packet where you put the source as H and the destination as G, and you want to send this packet. So that's our goal, taking this packet from the host all the way to the Google server. Now let's see how what all we have learned helps in this particular process. But first, let's look at the underlying network architecture. So here is your host. So here you are, and this is your host. This host in turn is often plugged into a switch. Now this switch will serve other hosts as well. These could be your friends, and it in turn could be connected to another switch, which in turn will be connected to another switch, and each of these switches are going to serve a whole bunch of hosts. Finally, one of these switches will be hooked on to a router. Your host as well as these other hosts, when they're configured, they already know what the IP address of this router is. Now let's see what does this mean in terms of the network, link and the physical layer. This interconnection, by the way, let's assume happens to reside within the CSE department building. This interconnection of devices, I can represent it at the link layer by this particular figure, where this is your computer, these are your friend's computer, and this is the router. So at the link layer, it appears as if each of these hosts is the next hop. So as far as link layer is concerned, The job is to deliver a packet to the next hop, so it will manage how to deliver whatever packet you are generating to the next hop. So this, even though there are multiple interconnections, as far as the link layer is concerned, this is how the link layer views this particular network of devices. As far as the network layer is concerned, we view this entire interconnection as a subnet, where all the hosts within this subnet have a common network portion. So when I was covering the subnet, I was mentioning this physical network. So this is what is a physical network. This entire thing, or the equivalent representation of this, is what I call a physical network. At the network layer, if you were to generate a packet that is destined to someone within the same physical network or within the same subnetwork, it is as if you are sending it to your next hop neighbor. So this is the impression that it creates, so you can directly send it out on the link. So the network task there is easy. It just has to identify whether the destination belongs to the same subnet or not. If it belongs to the same subnet, it passes on the responsibility for this to the link layer. And now let's see how does the link layer handle this. So before we even get to here, I mentioned earlier that ARP is needed to determine the MAC address corresponding to the destination IP. Let's say this is already in place. Now it is the job of the link layer to deliver this packet to the specific destination MAC. Well, we started out with the Google packet. We will get there, but right now we are looking at how to deliver a packet to another host belonging to the same subnetwork. For the link layer to deliver it, we talked about the need for framing, the need for error detection, the need for reliable transfer, the need for media access control, so on and so forth. The use of all this one could relate to directly if the architecture was indeed like this, but the use of switches tends to complicate things. As far as you're concerned, at the link layer, the next hop is the router, but the reality is that you are not directly connected to R. So the switches somehow give you the impression that you are directly connected, but they do something more sophisticated. So if you see the framing, the error detection, the reliable transfer if at all, and the media access control is happening as part of this. So if it is Ethernet, the media access control comes into play only if this is a half duplex link. Reliability doesn't even come into play, but the other aspects come into play over this particular link, and this repeats over every one of these links. Now, because you have complicated the link layer through the use of switches, we also saw that there was a need for things like spanning tree and learning bridges. So by the use of all these mechanisms, this packet that was generated by this particular host will reach the specific destination. If it were the Google packet that we were talking about, it knows that it has to send it to this router because the network layer will tell that the destination does not belong to the subnet. Thereby, the packet gets routed through the switches all the way to this router. So the packet has now come to the router. Now, where does the physical layer come into play? Whenever there is a link, you need to transfer the bits over the link, for which you need to convert the bits into signals, for which you need to do encoding, and this is where the physical layer comes into play. So here is you again. I have represented that entire extended LAN switched operation by this equivalent figure, where not only you, your other friends are also connected to the router. This is our CSC department building. Within IIT Bombay, we have not only CSC, we have electrical that is being served by another router, and there are other departments that are being served, so on and so forth, where all these routers within the IITB are interconnected. Finally, they reach this particular router R5, which is our interface to the outside world. So let's again see what's happening at the network layer. As far as the network layer is concerned, this will be one subnet, this one will be another subnet, this other department here will be another subnet, so on and so forth, and these routers are interconnecting them. Now all these routers that are interconnecting them will execute a intra-domain routing protocol, let's say the RIP or the OSPF. Now based on this, they know how to reach the different subnets. For example, if you have a packet for someone in the electrical department, the router R1 via participating to this will know that the path to this is maybe like this. Or maybe if this is more expensive, it may also send like this. But your packet that you have generated for Google is not for within the IIT Bombay, it is outside IIT Bombay. So how does this router R1 know to send to R5? So for this, RF injects this particular default address 0.0.0.0 into the routing domain. Basically what this tells is I can reach anything that is outside IITB. Now going back to our Google packet, now R1 knows that since this is not within IITB, it knows that this corresponds to this default address, so it is going to route it all the way to R5. Now what R5 does is it is now going to drop this packet into this ISP. It is now the headache of this ISP to route the packet to the Google server. That is handled by the router R6. Where is our packet? It has now been dumped into the ISP1. Notice that along this entire process, along each of these hops, there is a link and a file layer that is operational in moving the packet to the next hop. This ISP now also has an interior gateway protocol like RIP or OSPF. Not only that, it also implements a border gateway protocol, the BGP protocol, and interacts with the other ISPs. As part of this process, it figures out that the path to reach Google server is, let's say, via this autonomous system 1, via autonomous system 3, via autonomous system 4 to the Google organization. We have earlier seen how the BGP via eBGP and iBGP will internally, in conjunction with the IGP that is being done within the particular routing domain, control the forwarding tables at a given router. So this packet that has come will somehow route it through the IGP all the way here, and from here it will dump into this ISP3, which will again route it. Again through ISP4 it will again route it, and once it reaches the Google router, here again the individual routers maintain the subnet information within Google, and finally they will route it to the particular server. So that's how your packet goes all the way from your machine to the Google server by making use of the network layer functionality, the link layer functionality, and the physical layer functionality.